Authored by veteran chemistry teacher Abdul Shakur, these two textbooks provide all the essentials that would not only enable students to master grade 11 chemistry, but to excel at the next higher level in this subject. What make these texts unique are their creativity and profundity with which concepts are explained for clarity and mastery. The following is one of a set of 44 different tutorials created by the author, using materials primarily from the text Chemistry 11 in Focus. I hope you enjoyed this video. If you liked it, please give it a thumbs up and don't forget to subscribe. We will see you in the next video and thank you for watching.
Our lesson deals with the effects of dissolved chemicals on water quality. We will look at the effects of organic waste and fertilizers on dissolved oxygen in water. And I've created an activity to show the effects of biodegradable organic matter on dissolved gases. So read this little paragraph here as it sets the basis for what we'll be talking about later on. Water, being a universal solvent, has the ability to dissolve a wide range of substances. Because of this, naturally pure water does not exist. The majority of naturally dissolved substances pose very little health risk to humans and no danger to the environment if their concentrations are maintained within certain acceptable ranges. However, it is human activities coupled with the usage of a wide range of synthetic substances that are mostly responsible for the introduction of harmful substances, we call it pollutants, to bodies of water, land, and air. Despite this, some pollutants can be tolerated by humans with minimum health risk if their concentrations are maintained within certain ranges, but some of these can be deleterious in very minute concentration. It is therefore incumbent upon us that we become more aware of the nature of these pollutants and take the necessary steps to control their uses and disposal in the safest possible ways. Undesirable substances find their way into water in a number of ways, and these are outlined as follows. I'm going to show you a number of ways by which these kind of pollutants enter waterways. So one, as water flows over the Earth's surface or percolates through it, it dissolves or leaches any substance that is soluble in it. So it's showing here water is running over this piece of land here, okay, soil, and you can see as it moves, it is dissolving anything in its way that's soluble in it. So you can have carbonates, bicarbonates, calcium, magnesium, ammonia, iron, potassium, sulfate, iodine, and a whole range of other substances that can easily be dissolved by water. That's why we're saying that a natural water in a lake or a river or a pond is not pure water, because it will have dissolved in it these various types of substances to varying degrees. Another way is from industrial waste. Here have a little industry for convenience or drawing good. What we're saying is that from industrial waste and untreated sewage that are deliberately or inadvertently dumped into lakes and rivers and other bodies of water. And you can see how many different types of substances can get into a body of water from these industries. You have different types of industries, and they produce different types of waste products. You can see pesticides, you can have organic waste, hydrocarbons, microorganisms, and this host of different inorganic substances that may include poisonous ions such as lead, mercury, runoff from agricultural farm and feeding lots. Okay? So if you have an agricultural farm, or if you live in places like, say, where I came from, Guyana, you would have noticed that they have these rice and sugar plantations. And periodically, they will employ people to sprinkle fertilizers into the fields there for better growth of the crops, of course. But what will happen inevitably as rain falls, some of the fertilizers, not only fertilizers, but pesticides also, and some of that get leached from the soil and they enter these canals, rivers, wherever these agricultural farms are. And of course you have feeding lots. That's where you have cattle being fed with different types of food. But what is happening here is that they'll be producing feces and urine and stuff like that. And that will inevitably get washed out from the soil and find their way into waterways like that. You'll have dissolved solids, you'll have urea, and anything that they produce there. So that's number of ways there. And then you can have, we've spoken about this already, from acid precipitation, rain, hail, or snow. Of course, we've spoken about these gases, carbon dioxide, nitrogen dioxide, and sulfur dioxide, are produced from the burning of fossil fuels. And then when they react with the water from those sources, they produce these types of acid. And these acid, of course, can ionize to produce these radicals like hydrogen carbonate radicals, nitrate radicals, nitrate radicals, hydrogen sulfite radicals, and that these will find their way also in water. These substances affect water quality in a number of ways. Calcium, magnesium ions will cause hardness of water. We discussed that already. Carbonates, bicarbonates, and lime will increase the alkalinity of the water, affecting its pH, of course. Sodium ions, all these pesticides, lead, mercury, all these ions here are poisonous, and they can have direct or insidious effect on people. Then you have microorganisms. Of course, we talk about that when we talk about sewage treatment. You can have coliform bacteria, and these can be infectious and deadly. You have dissolved solids. Dissolved solids affect transparency of the water, and of course, if the water is not very transparent, it will affect photosynthesis there, because light will not penetrate for there to be productivity in that body of water. Then you have hydrogen ions from acid rain that affect the acidity of the soil and water. Nitrates and phosphorus will cause something called algal bloom, and that is what we were talking about now. All right. So now we look at organic waste and fertilizers on dissolved oxygen. So we're saying here that biodegradable waste, such as those found in sewage, affect the amount of dissolved oxygen in water directly or indirectly. Organic waste serves as food for microbes such as bacteria and protozoans. So when you pour organic material in water, you're feeding these bacteria or these microbes, call them microbes, and it thus quickens their growth. There's proliferation of these microbes. Decomposition of waste has a direct impact on the amount of dissolved oxygen in water. As aerobic bacteria feed on organic waste, they inevitably use some of the dissolved oxygen to do that. But the point is this: when you put these organic waste in water, it causes proliferation of microbes that feed on them because they're getting food for growth. But their activities now require oxygen. So these microbes will use oxygen that is dissolved in the water, which is normally used by the fish and other beneficial organisms for their cellular respiration. So what we're seeing here, the presence of organic waste in water thus increases the demand for dissolved oxygen. So normally we're only having fish and other aquatic organisms that are getting their fair supply of oxygen dissolved in the water. When you put the organic waste inside there now, because of the proliferation and the growth of these microbes and their activities, the amount of oxygen that's dissolved in the water gets less. So there's a greater demand for oxygen as a result of the increased activities of these microbes. This concept is referred to as BOD, biological oxygen demand. So listen to this. Scientists use the amount of organic matter in water, organic carbon in water, as a measure of BOD, as a measure of the biological oxygen demand of the water, since the breakdown of these is commensurate with oxygen usage by microbes. What that means, the more organic waste we have, we're saying that the BOD increases because oxygen usage is proportional to that. If you put a lot of organic waste in the water, the BOD of the water increases. That's all that it means, right? Okay, so let's look at some things that's happening here. I've taken a natural source of water in which we do not pour any organic waste. So naturally in this body of water, you're going to have gases from the atmosphere dissolving inside. Carbon dioxide will go in, oxygen will go in, and you have two processes here that are taking place in the body of water that affect the concentration of oxygen and carbon dioxide. Photosynthesis is taking place in the water by aquatic plants, and they're using carbon dioxide and changing it to oxygen. So in normal circumstances, more oxygen is produced than is used. So you find that there's a net diffusion of carbon dioxide from the atmosphere into the water because there's a lot of aquatic plants living in the water, billions of tons of these microscopic plants, we call them algae, and lots of photosynthesis is taking place here. And it is said that more photosynthesis takes place in aquatic organisms than in terrestrial plants. Another point I want to make to you is this. One thing that facilitates the diffusion of gases in water is churning effect at the top here. If you have stagnant water as opposed to water that is moving and like waves are being created, little ripples are happening here, it facilitates the diffusion of these gases into water because of the mixing that is taking place. Where you have stagnant water, there's less diffusion of gases from the atmosphere into that body of water. These are some points I want to make there. So in a normal body of water, you have a nice equilibrium that exists between the amount of oxygen going in and out and carbon dioxide in and out. And nothing is affecting that natural process that's happening there. See what happens now when we put biological waste into water. When we put biological waste into water, now we're going to call that BOD, right? Look what happens. Aerobic bacteria will decompose these, all right, and use some of them to produce its own energy. So in so doing, it's taking oxygen and changing it into carbon dioxide, right? Not only that, when you break down these things, it releases some amount of phosphates and nitrate that was normally trapped inside those molecules, okay? So three things are happening here. One, oxygen is being changed to carbon dioxide. Breakdown of these produces some minerals. But the most important thing to note is that there is oxygen depletion here. But we want to talk about the creation and effects of an algal bloom. The release of phosphate and nitrate ions from the decomposition process, along with any added manufactured fertilizers to water, may lead to excessive growth of algae and other aquatic plants. Okay, now listen to this. This rapid growth is referred to as an algal bloom. All of a sudden the water blooms with algae, okay? What does this do? Apart from blocking light for photosynthesis, the algae eventually die because of competition for space and nutrients. Look at a scenario like this. We had 10 people in this hall, and then all of a sudden 200 people have to be accommodated. What will happen? You only have a certain amount of food in the house, toilet facilities and so on. There will be lots of competition between people for food and other places to get rid of the excrement and stuff like that. Same thing is happening now. Because of this algal bloom, there is not enough nutrients there to sustain them. And eventually they die. So when they die, what happens? They create more organic matter for decomposition. See? So now, bacteria and microbes have to decompose more. Okay? So the microbial activity will increase. And when their activity increase, what happens? They use up more oxygen. So that is what now will create more oxygen depletion. So we call that the effects of an algal bloom. In severe cases, because of so much oxygen depletion, it can lead to extensive fish death. I want to talk a little bit about fish farming. People do inland fish farming sometimes. Fertilize the water. When you fertilize the water, it encourages the growth of algae because they want the fish to feed on the algae. What will happen if they over-fertilize? If they over-fertilize, they create some degree of algal blooming, okay? And that will have a negative effect on the fish for reasons we just described just now. So they have to really balance. They have to balance the amount of fertilizers that they put inside, that it just causes enough algae to grow that sustain the life of the fish there without causing any oxygen depletion here. There's something that's called eutrophication of lakes. That's when inadvertently the lakes become polluted from many human activities there, runoff from agricultural farms and feeding lots and stuff like that. So you create lots of algal growth inside there and affects the water quality, and it can even cause dead zones. You know, there's shorelines and so on like that. We have lots of these algal bloom. Productivity in those places will be very, very low. A reduction in amount of fish. Water will smell very badly. And of course, the water quality is affected there. In my country of Guyana, sometimes they have these industries where they have sugar plantation and they have where the sugar factories are. Sometimes they have these breweries, right, where they make alcohol. And sometimes they pump all these waste substances into these canals and so on. And this is what happens. They create anaerobic conditions and lots of foully smelling things, and smell the stench of the canals there for months and months. There's a permanent stench there because of all the organic waste that they pour into the canals there. Now we have an activity which I have created myself. Nobody has ever created this activity. So we will look at effects of biodegradable matter on dissolved gases. We will look at how it affects carbon dioxide and oxygen concentration of water, right? So this is some background information you ought to know. Let us say bacteria is acting on glucose molecule for its respiration. This is the equation for cellular respiration. This is glucose molecule being respired, and it produces water and carbon dioxide gas. So effectively, oxygen is being used and carbon dioxide is being released. And of course, the microbe gets its energy there, okay? Okay, so this is what this paragraph is telling you here. During cellular respiration in aquatic organisms, carbon dioxide is produced, it gets dissolved in water, and it produces a weak acid that's called carbonic acid. Carbonic acid can be detected by an indicator called bromotimal blue. Depending on the concentration of the carbonic acid produced, the bromotimal blue indicator changes color, as I have tried to indicate here, from blue to light green to light yellow to a deeper yellow here. So depending on how much carbon dioxide is produced, you'll see one of these colors here. You can demonstrate this in your class by taking some bromotimal blue in a test tube and you blow into it with a straw. You're blowing in carbon dioxide inside. The moment you started blowing inside, you'll see it started changing gradually, right? If you continue blowing, eventually you'll end up with a color like this here, okay? And that is the effect of carbon dioxide on bromotimal blue indicator. We'll use this color change to monitor the amount of carbon dioxide in the activity that follows. So hold that in mind. There's another indicator that we're going to use that's called methylene blue. Only in this case, we're measuring the amount of oxygen that has been removed from the water. In oxygenated water, normal water, methylene blue has this nice, beautiful blue color there, okay? Now, if we start to deprive this water of oxygen, we deplete it of oxygen, right? As the oxygen molecules are removed, the bromothymol blue molecules become colorless, okay? And if you were to remove all the oxygen from inside there, the entire solution becomes colorless. So the change in color from blue to colorless will depend on the degree of removal of oxygen from the water. So this one will be used to monitor the amount of oxygen that will be removed from a solution. We will use decaying rice as our organic material, and the bacteria on the rice will represent the decomposers. So what I did there, I left some rice for a few days to spoil in a little bit of water there, okay? And that is what I'm going to use now in this activity. So you get 10 test tubes, 2 test tube racks, 10 stoppers, decaying rice, methylene blue, on that bromothymol blue, and distilled. That's all you need, okay? So what we're assuming in this here, we're assuming that every additional grain of decaying rice contributes more BOD and microbes. So I'm assuming in this activity here that if I use 2 grains of rice, 2 grains of rice will have a certain amount of bacteria. If I use 4 grains of rice, I'm assuming it has more bacteria, right? And of course, I'm putting in there more organic matter to be decomposed or more BOD. Okay? So this is what we'll do now. We will label 10 test tubes, you label them like that, right? Okay. So you have 2 test tube racks. You put 5 of them in one rack. So you put 2 drops of methylene blue into each of the 5 test tubes. So you have the first rack with 5 test tubes. We put 2 drops of methylene blue inside. We'll leave test tube 1 as a control. We're not putting in any decaying rice in test tube 1. In test tube 2, we put 2 grains of rice. Test tube 3, 4 grains of rice. Test tube 4, 6. Test tube 5, 8 grains. What we'll do now, you use about 8 milliliters of water, and you pour that into each of these test tubes. So use a dropper and use about that amount of distilled water to ensure that total volume will be the same, right? The other 5 test tube now, okay? The one that's labeled test tube 6, leave that alone, but inside each test tube, put 4 drops of bromothymol blue into each. Test tube number 6 will have only 4 drops of bromothymol blue, and the rest will have same 4 drops too, but now look what happens. You put 2 grains of rice in test tube 7, 4 in test tube 8, 6 in test tube 9, and of course 8 in test tube 10. Using a dropper, add water to each test tube such that they have the same volume as the previous 5. Stop with these and observe for the next few days. The moment you stop with these, don't touch them at all, leave them to stand in the racks. So I want you now to make hypotheses in your own way. If you leave these racks there after a few days, what you expect to see. Think about it in your mind based on background information you have. All right? You can think about that. This is what you get. This is what I got. This was test tube 1 without any rice. This was test tube 6 without any rice again. This one had methylene blue. This one had bromothymol blue. You can see that the amount of oxygen that's used up. So in that way, in that direction here, we can say more and more oxygen is used up. So this test tube will have less and less oxygen inside. But look in this direction. What is happening here? What are you producing? More what? You're producing more. Very good. If you said carbon dioxide here, the carbon dioxide CO2 increases in that direction. All right? but the oxygen gets less. So oxygen gets less in that direction here. So you have less O2. Anybody wants to explain what is happening there? Beautiful. How do you explain that? Let's use the left side first. Okay. They got 2 grains of rice, 4 grains, 6 grains, 8 grains of rice. Where did we have more microbial activity or less? In this one, you had the greatest degree of microbial activity. Less in this one, less in this one, less in this one. Because of a higher amount of BOD there, as you move in that direction, microbial activity increases more in that direction, and therefore oxygen depletion gets more and more in that direction. Since oxygen usage is commensurate with carbon dioxide production, as respiration is taking place here, oxygen is being removed from the water and carbon dioxide is being produced. So you have little amount of oxygen being removed and little amount of carbon dioxide produced, little amount of more oxygen being removed, more carbon dioxide being produced, same thing. And that is what you're seeing across here. So little amount of carbon dioxide being produced here, more here, more here, more here. So you can see the relationship here between the amount of oxygen being absorbed and the amount of carbon dioxide being produced. So a body of water that has lots of BOD will have less oxygen as depicted by the change in color here, okay? And will produce lots of carbon dioxide as depicted in this color here. So I hope you understand that, okay? And it's a neat little activity that you can do in a school to show your students this, okay? Let me see what else we have to talk about here. And that's it. There's some questions here for you to answer. Okay? In which test tube was the least amount of carbon dioxide? Which test tube greatest amount of carbon dioxide? Which is least amount? And I have answered some of those for you there. Some nice questions here. Make a concluded statement about the relation between carbon, the amount of organic matter, and the amount of oxygen dissolved. Do you agree with the hypothesis? All right. What is the purpose of test tubes? What? 6. Okay. And these are some nice questions there. The answers are from a solution manual. Don't want to give you that. Nice questions there. Why do municipalities construct spillways along courses of water? If you have a polluted river, what they do sometimes, they have these spillways there, little drops there. So the water is going to fall down here, fall down there. Why you think these are created here? I mentioned a little bit about that when I said water that churns up has more dissolved oxygen inside. Okay? And here I have some nice questions for you to do. True and false. Okay, matching questions. And a series of multiple choice questions. So these are found in the solution manuals and the answers to these are provided. I hope that was informative.